Evet, teşekkür ederim. Merhabalar, ben Anoosheh Iravanian. Well, I forgot that I'm going to talk in English. I wish I knew it before. So I work in nearest university, and I'm going to talk about is it? Okay. Evet. So I'm going to talk about using plastic solid waste in soil stabilization process as a geo-environmental solution. So I'm going to talk about my outline. I'm going to give an introduction, problem statement, what's the idea, why we came up with the solution, the methodology of the work, results, and the conclusion. Introduction, as we know, weak clay, expansive clay, all over the Cyprus, not only in Cyprus, everywhere. So it causes damaged ways and damaged structures, especially in light structures. Therefore, we need to improve the soil, or if it is at a terrible statement, we have to replace it. So both replacement and improvement, they cause an environmental damages. So on the other hand, we already are dealing with some environmental damage, which is waste disposal problem, mostly with plastic. So here are some pictures that I took around the areas that I was walking. I didn't go certainly for looking for cracks and problems. They just come in front of you. It's Cyprus. So this one, for example, it's taken in north of Kyrenia. Using untreated soil, we have, underneath this, it's difficult to see that really. So here we can see the soil, the expansive soil, this disintegrated material. We can see the cracks, the alligator cracks at the sides. You can see the heaves. So like all the combination. Next, we have these pictures. The left one is in the Kyrenia city center. As you can see, the crack, it's because of the, you can say it's because of the expansive soil or differential settlement in the middle. The structure is light, so that's easy to happen. At the right side, again, another cracked and tilted wall. So this one is my favorite. I was in the Lefkoşa city center, Yenişehir, to do some work, and I saw this wall, which is the garden wall of a school. So I didn't have anyone to stand there as a scale, so I put my finger over there. The walls, they have like certain columns in between. The columns are heavier, so they're like keeping the wall. But in the middle, when it gets lighter, we had these repetitive cracks. This is the worst case, but there were other cracks as well, like continuously in this. So that's obvious that the soil is not good. So in the left side here, it's the typical diagonal crack that we talk about it in when you're talking about on clays and expansive soils, in differential settlement. It shows this the cracks, the diagonal cracks at the sides of the walls and windows and the places that it's lighter within the structure. So the right one doesn't have much to do with expansive soil, but this is after that disaster that happened in Cyprus. After we have prolonged raining in 2019, I think it was. This is taken in Pınarbaşı. So you can see that from the muds over here, you can see that the look is even clay. It's all clay. So the clay, it absorbs water. It can hold a lot of water. So when the drainage is not fine enough, and when there is no other way shown to this water to go out, the poor water pressure at the back of the retaining wall builds up, and at a certain point, this retaining wall at the rest condition will go to active condition. That's what happened here. So problem, these are problems. What is the solution? Solution, one of the oldest things that we know as human, okay, that's bad, let's remove it, let's throw it out. Replacement, the poor soil by excavation. But it has two problems. First of all is that it needs place to dump that poor soil. The second one is that, okay, we got the poor soil out. We are going to take a good soil instead, a filling material, right? So that filling material must be somewhere close, economic to be taken. So what is the most best filling material that we have? Crushed stone. Okay, in Cyprus we have it a lot, right? It's abundant, it's close by, we have it Beşparmak right over here, and it's easier to achieve. So it's solved, right? No. So let's take a look at the picture that it is taken at 1963 from the Değirmenlik area, the part that we have these quarries. So at 1963, nothing over here. Now if you open the Google Earth, you will see this picture. So we can see that in that area, about 70%, the morphology of this place is changed. Another picture, Değirmenlik. This is toward the same area, toward the north and west of the same area, and the mountain when you go from Kyrenia, from Lefkoşa toward the Kyrenia. So 1963, after 30 years, the quarries started. We needed filling material, aggregates, cement, everything. And take a look at this area and this area. Now we'll see that this change in the morphology and this quarry even increased more. So what should we do? Shall we stop it? Okay, let's stop quarrying. It cannot be possible. We are going to continue. We cannot stop that, okay, let's not do anything else. According to the Cyprus Turkish Building Contractors Association, the report that was made in 2020, a total number of 15,336 construction projects were permitted to be built, and they were unsafe. So they had a total area of about 3 million meters square. So this industry needs quarrying. So what I'm trying to say here is that, okay, since we need this crushed stone, let's keep it for the places that there is no replacement for it, instead of just using it as a backfill material, as a filling sub-base material for the in transportation. So what else do we have in Cyprus which is abundant and which is free? Trash. We have a lot of trash. So this picture is taken in an abandoned waste dumping area of Çatalköy. At the back, the area, the mountain that you see, is the north side of the same mountain that the quarrying is going on it. So this is like I asked, and according to the information I got from the Çatalköy Belediyesi, they said that it's more than 20 years old that this area is not being used. So I cannot really call this a landfill, because nothing has done to cover it or to do anything. So you can actually see this small parts of trash still over there, mostly plastic. And well, there are the materials that they were non-biodegradable. So let's say we have soil, which is problematic, and we have trash, which is free. If we mix them together, does it help us improve the soil? So I came up with, okay, let's stabilize the soil with this. Soil stabilization is the, sorry. Okay, I think I skipped one. So let's talk about the percentages of this trash, the normal trash that we saw in different landfills and in this landfill. According to the report of Çevre Dairesi in 2019, the collected trash, mostly were 55% was biodegradable, the kitchen waste. The second one after that was plastic waste, 18% plastic waste. Then it was coming the glass, other waste, metal, and paper. So this other waste includes the construction waste as well. I did another soil stabilization using construction tile waste, but I'm not going to talk about it here. In this work, I just worked on the plastic, like simple plastic, and I want it to be, like easy. I don't want to like shred it too much. I don't want to do another process on it to make it like more expensive. Like simple bags that you get from the shops, and then it goes to the trash. So estimated at 44,650 tons of plastic waste was wasted in 2016. And keep in mind that we are consuming in the same ratio, and because of the population growth, this by 2035 will increase to 67,500, about that. So let's mix these two. The plastic we collected from the areas and cafeterias within the nearest university campus. We got the sample, soil sample, clay soil sample inside the campus. That was not too much expansive, not too much stiff, something normal average that we can see it like in most of the areas. We want to see what is the effect of this plastic bag on this. So the tests that they were performed were Atterberg limits, like basic to see which kind of clay we have, standard Proctor compaction test, CBR, and unconfined compression test. So I think I skipped one slide over here. The types of soil stabilization that we have, it's mostly commonly used using cement. So cement is good because it improves the soil instantly, but the problem is that cement has a lot of CO2 emission. So we use only small percentage in soil stabilization. Yet, because we are using small percentage of cement, still we have this desiccation cracking problem. So we will need a fiber in it as well. So now I'm thinking of this nylon bag as fiber inside that to keep it together. So the soil sample was classified as a medium plastic clay, 49% liquid limit, 32% plastic limit, and plastic index of 17%. So optimum water content and maximum dry density was found using standard Proctor compaction test, and unconfined compressive test of this untreated sample was found to be 44 kilopascal. So the point here is that usually for doing the unconfined compressive strength test, we use small samples. These samples has huge fibers in it. So we could not really cut it in small samples. That would be, the samples wouldn't be identical otherwise. So we used the compaction mold as a mold for doing the test and prepare the bigger samples. So here I want to show you the kind of fiber that I'm talking about. It's like trash. So the thing is that we use 0.2%, 0.3%, and 0.4%. So when you say like 0.2%, they will think that that's such a small amount. But because the plastic is very light, you can see that 6 grams of it will make such a big volume. So that's the look of it after being compacted and the look of it after being crushed. So here you can see the compaction curves and unconfined compressive strength of it. So after 0.2%, using after 0.2% plastic, you can see that the maximum dry density, it starts to reduce. What's going on? It's moving. OK. It starts to get reduced because these fibers are going between the soil grains, and they're like actually disturbing the interlocking between the grains. So the density is actually reducing. So it's not that much good in that sense. Yet, as much as we increase the plastic content, the compressive strength increases. So the more plastic, the more compressive strength.
Anoosh, a few more minutes would be OK?
Yeah, about to finish. Right. So again, we did the CBR as well. Higher CBR will be achieved by higher content of plastic. So here if we want to use an optimum number for the plastic to have like the maximum dry density, yet to have a good strength, we would be talking about 0.3%. So yeah, conclusion and recommendation. The importance of soil stabilization were discussed in this research about reducing the resource exploitation. This study presents an example of plastic reuse. The work showed that mixing plastic shreds with a medium plastic clay improves the enduring properties of it in a level where it may be safely used as a subgrade soil in pavement, low-budget roads, and perhaps in temporary roads, not in big projects. As Cyprus is mostly covered by problematic clays, this approach needs to be further validated by being tested in situ. As Huriye Hocam also said, we do this test on small samples. We need to go there out and really check if it works on big scale as well. Addition of small portions of cement and pozzolanic material for further improvement in enduring properties should be studied because it's just the fiber side. We will need something to increase the cohesion as well. And here are my references. We published this work with a master's student. He got graduated in environmental earth science at 2021. And thank you, I guess I'm done.